start. Okay. So, if you guys remember, in our last session, we have seen how to work with how to create a cluster in the data prop. In today's session, let us try to see how we can create a PySpark job in the data prop. Okay, for example, if you have some kind of a data in the data prop in a Google Cloud Storage, so assume that this is a GCS bucket. In GCS bucket, if you have some data, maybe any file, some sample data you have, and you wanted to move this data to the BigQuery. We already know the BigQuery, right? So this is one of the common use case whenever they wanted to move the data into the Google BigQuery from the GCS bucket. So usually what happens is that so there will be a lot of CSV file, JSON file, Avro files, BigQuery files. So if you wanted to move the data from the GCS to the data to the BigQuery, we can use Dataproc for this purpose. Okay, so let us try to do this activity in the Dataproc today, so that you guys get some idea how people are moving the data from the Google Cloud Storage to the BigQuery. So for that one, we are going to use the Dataproc today. We are going to use WhatsApp. We are going to use Dataproc. So what is a Dataproc? So Dataproc is one of the fully managed service for running the Hadoop and Spark jobs. Here we are going to create a PySpark job for that. Okay, PySpark job. This job will be having WhatsApp. It will be extracting the data from the Google Cloud Storage. It will extract the data from the Google Cloud Storage and transform it and load it to the BigQuery. So this is what it is going to do. So let us try to do this activity. And while loading it to the BigQuery, it creates one of the table. You can call it as a sample table. Okay. So this is what is something that we are going to do it now. So we are going to extract the data from the GCS bucket and transform the data and loading the data to the BigQuery. So let us try to do this activity so that you guys get some idea how the PySpark job will be created in the Dataproc and how to run that PySpark job. Okay. So hope all can hear me. If you guys have any questions, you can ask me now. So let me gonna open the cluster. So this is a cluster that we have created in our last class. So first, let me gonna create a new PySpark job, guys. So I'm creating a PySpark job. So I'm gonna create it as I'm renaming it as okay PySpark job. So I'm renaming it as a PySpark job. So you guys can see here in the last session also I have told you if you wanted to create a PySpark job, you can click on this PySpark job so that the job will be created automatically. Okay. Once you have clicked on PySpark job, you can rename the PySpark job as your own name. So I have renamed it as a PySpark job. The very first thing is that wait a minute, the kernel status is unknown. Okay, I'm not sure why. Okay, let me check it. Meanwhile, if possible, let me activate the Cloud Shell as well. Something wrong with the kernel. It is so if that is not working, Kernel died unexpectedly. Something wrong with the server, guys. 1 minute. So let me restart it, or let's wait for 1 or 2 minutes. Something wrong with the kernel. Yeah, I think it's good. So import PySpark. The very first activity we do is that importing the PySpark. If you wanted to import the PySpark, we first install it. Pip install PySpark. So we already know, I have told you already. So first we install the PySpark. So it is already installed. We don't need to specifically install it. I'm just telling you guys. So once it is installed, we can import the PySpark. Okay. So if you wanted to run this cell, you can do click on this play button, or you can shift plus enter. Also, you can click on shift plus enter. I'm doing the shift plus enter, guys. Okay. Next thing is that we need to create the Spark session. Can anyone tell me what is a Spark session?
It's a Dataproc instance.
So usually a Spark session is nothing but an entry point to your Spark functionality. So Spark has a plenty of Spark is nothing but a framework. It has a plenty of functions are there, plenty of functionality is there. So if you wanted to do any kind of activity with the Spark session or a Spark context is the entry point. It's like a gatekeeper, or it's like a gateway. Okay, it's like a establishing a connection to your Spark functionality. Okay, so now Spark, you don't need to specifically create it, it's already created to let you know that this is how we have to create it. Okay, Spark session dot, I forgot it. Okay, so this is how, guys, Spark session dot builder. Yeah, yeah, Spark session dot builder. App name, you can give some application name. So I'm gonna say job, Spark job, Spark job. So this is how you have to create it. And master, you can mention local, and get or create. So this is how you have to create your Spark session, guys. So you don't need to specifically create, as I'm telling you already. Whenever you create a Dataproc instance, you click on a notebook. So automatically the Spark session might have already created. It uses the existing session only. Okay. So shift plus enter. See here, using the existing Spark session only. Okay. So this is how, if you wanted to install it, import it, and create a Spark session, so this is how you have to do it, guys. Now these things are not mandatory, just to let you know. Okay, now I'm going to delete it, okay, to avoid this confusion. Now very first thing I wanted to do is that we wanted to create a pipeline to move the data from GCS to BigQuery. Okay, this is what is our agenda. The very first step is that, so what is your sources connection? 3 steps I'm going to do. The next thing is that destination connection, oh sorry, transformation. If do you wanted to do any kind of a transformations? Okay, and the third thing is that And the third thing is that I wanted to do the destination. I wanted to move the data to the destination, nothing but a BigQuery. Okay, so the source connection is that how do you read the data from your source? Transformation is that on top of this data, do you want it to perform any kind of a transformations? And destination is that, and how do you want it to load this data to the destination? Okay, so this is how if you wanted to do any kind of a job, you must mention all of these things. For now, our source is GCS. In this step, our source is GCS and our destination is BigQuery. Okay, so let us try to read the data from the GCS. Okay, let me mention GCS path. So to this particular path, I wanted to, from this particular path, I wanted to read the data. Similarly, you will be having table ID. Okay, BQ table ID. So to this particular table, you wanted to load the data. Okay, to this particular path, you wanted to load this data, right? So let us try to mention both of these things. So what is your input GCS path? What is your output BigQuery table ID? So for that one, let me gonna open both GCS as well as BigQuery. So cloud storage, and similarly, I wanted to load the open the BigQuery also. You guys can see here. So take any of the bucket. I'm taking this bucket. Sir, in my bucket, I have this many tables are there. Okay. So let me gonna do one thing. Okay. Assume that. Okay. Let me go to the one more bucket. Maybe this bucket. So I have this many files. I'm going to delete all of these things now. So let me gonna load the CSV files, guys, so that you guys can look into it. What we are going to do now. So assume that I have a two CSV files. Okay, let me gonna open the two CSV files also. Look at here, guys. We have here students CSV is there. Similarly, we have a grade CSV is also there. So here we have the student CSV. In that we have a student ID, student name, gender, as well as age. In the grade CSV, we have the student ID, we have the subject, and we have the grade. Okay, so we have both of these tables are there. Both of these CSV files are there. Your client is asking you to load this data to a single table because this is related to the single students as well as grades only. So if they wanted to see the data, now they have to go to the multiple tables. Right now, if I wanted to see the student details, I am going to the students table. If I wanted to see the grades table, I wanted to go to the grades table. Now the client is asking is that we need to load this data. Both of these tables, we need to join it and we need to send this data to the one BigQuery table itself, so that if they wanted to see the student name who got some kind of a details and their age, gender, they can able to see it in a single table itself. Okay, so such kind of requirements will be there. First, let us try to read this data from these data sources and let us try to transform it. First, GCS path 1. So we have two files, right? So GCS path 1 and one more is GCS path 2. So first file is, you can click on here, students.csv, copy the path. And similarly, click on this particular grades.csv and click on that particular path as well, so that you can able to have the both of these paths. Okay, so now these are the source files, guys. So these are the two CSV files that you have the data with. Now we need to read the data and we need to create a data frame. Okay, we need to create a data frame, guys. First step is that. So these are the source CSV files. Okay, 1 minute. Let me mention here. Okay, let me mention here. First data frame one I am going to create it, sir. So data frame one is equal to, I wanted to read the data from this particular students.csv and create a data frame one. For that, spark.read.csv. So we are going to click on spark.read.csv and we are going to mention this path so that we are able to read the data from the CSV properly. Okay, spark.read.csv. Similarly, df2 is equal to, we wanted to read the data from the same thing, spark.read.csv, and this time path 2. So this way, we are creating both data frame 1 and data frame 2. What is a data frame? Sir, in PySpark, the data frame is one of the data structure to store your data. It is a multi-element data set to store your data, and it is having a schema and it is having its own optimization. Optimized. It is an optimized version of storing the data also. Okay, so it is a one of the data structure similar to the RDD, and RDD is a one of the fundamental data structure in the Python, PySpark. You can think of a Spark architecture where your data is stored in the form of a collections. Okay, now we are using the data frames. Most of the times people will be using the data frames only. If you wanted to see the data, you can select df1.show. If you mention df1.show, and if you wanted to print the schema also, you can mention df1.print schema. Okay, so this is how, if you wanted to see it, you can click on shift plus enter. What is that?
You declare the variable name same, Rahul. GCS path 1.
Oh, here it is. Okay.
Yes.
Oh, still something is wrong. I think there's something wrong with this particular thing, guys. 1 minute. Something wrong with this particular cluster. It seems like 1 minute. Okay, so I have created one more cluster also. I know that this is facing some issue. So that is the reason I have created a one more cluster. Where is that? It is not created. I started creating it. Cluster name, region, standards. Yeah, I have given it properly. What is the problem here? Hmm. Something wrong with that cluster, guys. It's been a lot many days. What is that? Okay, 1 minute. Let me see if I have any other cluster available in any other project. Should be having it one in other projects. Yeah, here I have cluster. Let me start this one, guys. So something wrong with that particular cluster. I'm not sure why, and hope you will be able to create it, because what is happening is that we are came to an end with my free trial account. So that means I might have exhausted the quota that on that particular project. So if you are exhausted the quota, that's where this kind of a thing's going to happen. So in that case, you can create a one more project and start using the services. Okay, in the free trial, so there is some kind of a quota for the services. If that quota is if that quota is totally completed, what you can do is that you can create a one more project, and in that particular project you can able to create your services. So that is something that you can do. So let us try to do this one. Something is wrong with this one, not sure why. So let me copy this entire code and go and paste it here. So 1 minute, guys. Meanwhile, if anyone have any questions, you can ask me related to the PySpark or Spark or anything.
So the question on the data proc means basically we are creating a cluster. It's like one machine or like multiple machines.
A cluster is nothing but a collection of machines, first thing. Okay, so a single machine cannot be able to complete that activity. So that's where Spark cluster we are going to create it. It's a distributed cluster and nothing but a distributed machines will be there. So all of them are connected so that whenever you wanted to do some task, the task will be split into those machines and it will be completed there in the executed in those machines. So that's how it works. That's how it
Okay.
happens. Yeah.
So it's managed by Google, right? So we
Yeah,
don't.
it's managed. This particular clusters are managed by the Google itself. Yes.
Yep. Okay, thank you, sir. So in real time, is this what they're going to do exactly? Like they create a PySpark job and all, just like the way you're showing it. That's
Yes,
what they
yes,
do.
they are going to do it. So first they are going to create a PySpark job and they test it whether everything is working or not. And then they are going to submit that particular job to here. So are they are automate it or they are going to schedule it. So once they schedule
Okay,
it every day, that particular PySpark job is running in the data pro cluster for some point of time every day. So
understood.
that is
Thank you,
how
sir.
we are. Any other questions, anyone?
So and also this data Spark and PySpark job is only handle structured data, correct, right, sir?
No, 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 no. Even you can work with semi-structured data and unstructured data also, because it's a Spark. Spark has its own functionality to work with any other most of the types of the data. You can able to store semi-structured data and logs kind of a data also. You can able to work with that. And the Spark is having an extensive library. With the Spark, you can able to work with machine learning models if you wanted to create it, and graph relations, graph because it supports the graph also. It has total four components are there. One of the component is SQL, one more is streaming, and one more is machine learning. Nothing but a MLib machine learning library, and it is also having graph library as well. So if you wanted to work with any of these things, you can able to work with.
So PySpark built on a Python or is a different model?
PySpark is nothing but a Python with Spark.
Python. Okay, thank you, sir. Thank you.
So let me open it here, guys. So let us now try to see it, and let me copy this one and paste it here. What I will do, okay. So is this my cluster? Yes. So I'm going to create here PySpark job. So you click on here, this PySpark notebook. You paste here the entire thing. Is something wrong today with the clusters or what? No, what I can do. Kernel is terminating. I'm not initializing, connecting, unknown. Not sure why something is wrong today. Same thing. Here also it's not working here. It's not able to initiate it. So thought of like a cluster issue. But here also, I'm not sure. Some clusters are not running today. Maybe did I use exhaust my entire code? Or okay, it came. Let me see. Okay, it is now idle. So what I will do? Let me run it now. Okay, let me run it, guys. So I'm running it so that you guys can see here something is wrong today. Okay, error accessing the file. Yes. So we need to change the bucket. So the bucket name is this one. So this one, if I put it, it will be able to run it. Yeah. Okay. You guys can able to see that. See, we are creating a data frame from the CSV file. That to read the data from the CSV file, we need to use spark.read.csv. If it is a JSON file, spark.read.json. And if it is a Avro file, spark.read.avro or Parquet, whatever it is, you can able to do it. And we are able to show the data frame 1. Similarly, if you wanted to see the data frame 2 also, so that is nothing but data frame 1 is your students data, data frame 2 is your grades data. So now you guys can see it. So what is the problem? Can anyone tell me with that by reading the data, we are doing some mistake. Can anyone tell me what is the mistake that we are doing here?
We are reading column headers as a
So we are
data.
not reading the column headers properly. So that's the reason it is creating the extra columns, right? So if you while you are wanted to read the columns also properly, if your file is having the column header, you can mention header is equal to true. So that if you mention header is equal to true, so automatically it reads the columns also from it. Okay, so this is something that we have to mention it. So now if you mention it, sorry, here we need to mention df2. Okay, so this is how something is wrong with the cluster today. Something is wrong. Again, kernel issue, trying to connect it to the Java server. So 1 minute, guys, let me restart it. Not sure why is that happening. Anyway, we can write the code for the df2 as well if you wanted to look at the data. Okay, so this is how, if you are reading the data from the Spark, from the CSV file, you are printing the data, you are printing the schema also. So for this is for the student CSV and this is for grades CSV. Now what we have to do? Now we need to properly transform this data. See, we here we have df1, here we have df2. So what we can do is that we can join the data, right? So you guys can see here the data, right? I'll also show here the data. So here it is showing the data already. Okay. So what I will do, I will mention here 3 records, and here also I will mention 3 records so that it will show three records only. Let me run this one. Okay, it's only showing 1 record. Okay. Something is wrong with today. It got struck, guys.
It says in the bottom busy. PySpark is busy.
Yeah. I'm not sure what's happening today with the clusters. I didn't face this kind of an issue so far. Something wrong with the cluster. Okay. No, it's very slow. I can't even stop it. Control X. Nope. Okay, guys, I think I'm gonna stop it here. I'm not sure why it is behaving like this today and what is the problem. I'm not totally sure. We will try to see this one tomorrow, guys. Okay, it's
So,
already 15. I mean, if I can't complete it today.
sir, one quick question, sir.
Yes.
In the Python, so we are running on Python on the PySpark. Where do we select the versions? Which version is running on? How do we know which Python version, which
You
PySpark
can
version?
go here and you can able to check it here. Okay, because you are creating the data pro cluster, it picks up the latest version. If you wanted to see the entire thing, you can able to click on the Spark history.
Okay, okay.
So you have the plenty of the details here, so you will be able to check it here, which year version it is actually using. I think we can go to the Spark. You can go to the Spark history server. You'll be able to see the entire details here.
Yeah, sure, sir.
So even though you are running some jobs, and you will be able to see the entire history of the jobs also. See here, we have ran so far. Just now we are running something, right? So it is yeah, Spark shell application name. I'm not sure why it's taking this much time today. Stages. Each application converts into stages and number of tasks, guys. So that's how it happens in the backend. Okay. Yeah. Now it seems like it's working. Okay. It's just first. Okay. Anyway, I'm stopping here the session, guys. I don't wanted to tell it something which is not working all the time. We should not face any errors while creating the jobs, because creating a job is one of the important aspect. I'm going to tell you tomorrow, guys, and I will also tell you one more thing also tomorrow. Now I'm going to stop here the session for today. And if you guys have any questions, you can ask me. And if you have created a cluster, don't forget to stop it. Otherwise, it is going to be very costly. It eats up your entire free credits. Yes, please.
So one question.
Yes,
If
please.
the
Yeah.
if the file size is more than 1 TB or 2 TB, will that framework will take care of that? You mentioned, right? df1 equal to spark.read.csv.
Correct.
So
Yes, it will be able to read it. It's not a problem. Yes.
how much time for it will take for to read that entire 1 TB or 2 TB of data into that
No, no,
target?
it doesn't do. It doesn't take that much time. It will hardly take few seconds or few minutes only.
Okay.
Yeah, it doesn't take much time because Sparks is an extensive library, and it will be able to work with large amounts of the data, petabytes of the data. Also, you'll be able to work with it. So usually while reading it, so usually what happens is that maybe spark.read.csv you might have given, and it will show you sample data, but in the backend it will keep on working on the data. Because what happens when you give spark.read.csv, it does not directly read it. Okay, Spark transformations are lazy. So what happens in the Spark is that so even though when you are giving when you are doing any kind of a transformations, Spark transformations are lazy transformations, we call it as. So as soon as you mention Spark dot read dot csv, okay, it does not read the data like that directly. Okay, you mention it like this, but it does not read the data like this. What happens is that, so you do again, you created a data frame one, and out of this data frame you transforming the data again, you are transforming the data. Finally you are calling an action. Okay, if you want, if you when you call an action, then this step to this step, this step to this step, this step to this step, all these steps will be, now it will be running. So that is how the Spark will do. Spark is a lazy transformations. So all the transformations, whatever you are doing on top of the data frame, it never happens, or the results are not written right away. So what it will do, these transformations are lazy, that whenever you mention also, it will not return the results right away. So it will create an execution plan first. Whenever you are calling an action, this is an action. Dot show is an action. Dot collect is an action. So whenever you are calling that an action, so what internally happens is that this DAG, this is a DAG, direct acyclic graph, we call it as a logical plan. A logical plan will be running behind the scene. First it will read the data, then it will do the transformation, then finally it will return the data like this. So that is what happens. So that is the reason first when we do the df1, df1 is equal to spark dot read dot csv, it does not read the data. So that's how it works. So this kind of a behavior is very useful for the optimization, because so what internally Spark will do is that it creates a DAG, nothing but a logical plan. And when the logical plan has created, while it is executing, that we call as a physical plan. While it is creating a physical plan, it converts the entire code into stages. The application will be converted into stages. Stages will be converted into tasks. That way, it will even optimize the data. So that's how the Spark is very famous, because of its extensive library and optimization techniques. Okay, yeah. So two plans will be created, yeah.
Yeah, one more question. In initial sessions, you were telling that if a client want to store 1 TB of file for quicker access and something, we will go for Google Cloud Storage, right? Okay.
Yes.
So how the client will share that 1 TB file, because they cannot share it directly, right? Somewhere they have to put it in the file system or something. How will we get that 1 TB file and store in the GCS?
No, it's your choice. As I told you, you can move the data from the GCS, any other file server to the GCS easily.
Yeah.
You're able to move any from file server to the GCS easily. So
yeah,
sir,
they will share only the location, file location, not the entire file, right?
That's what I mean. When they share the location, that means they are sharing the file link and file path where it is available.
Okay.
Right.
So from there we will copy that file into GCS.
We don't actually manually copy it. We use the commands to do that. So you can use GCS. What we can use is that copy command. Okay, gsutil copy command we can use. Gsutil copy command. So when you use gsutil copy command and source path and destination path.
Same
source
like Linux command.
Linux command. Source path you give this path, and destination path is your GCS path. So that the data will be automatically moved. You don't need to worry about it. And that 1 TB is very less. It will be doing very faster.
Yeah.
Okay, yeah. So that is what. It depends on your file location and how it is managed. Okay, 1 GB, 1 TB of the data can be moved easily. Yeah.
Thank you.
Yes. Any other questions, anyone? I'm really sorry for the day. So the cluster was not working properly. So I can't do anything. So we will see this data proc on the next session, guys. I will try to tell you. So we are only left with the data proc job and data flow one job. Okay, data flow job and airflow job. So once I complete these 3 sessions, this will take 3 days. Okay, not more than that. Once these 3 sessions are completed, we will see the end-to-end pipeline. Okay, so that is what we are going to see, end-to-end pipeline. Okay, so with this one, we are going to see the end-to-end pipe. Okay, yeah. Okay, guys, thank you all. We will meet tomorrow.
Thank you, sir. Bye.
Thank you. Yeah, bye. Bye-bye, guys. Yeah, have a great day.